All right, guys, just going to go over a couple of them, so this should help you on your Unit 7 exam. First question on the first page is, what are the zeros of the function? So remember, zeros are where the solutions are, where the parabola crosses the x-axis. And I can see, because it gives me the graph, that the zeros are at -1 and 3. So that's the first answer. Which of the following, number 2, which of the following is the vertex of the graph? So remember, this is written in vertex form, so it's very easy to find out what the vertex is. All you have to do is look inside the parentheses, and that's going to be where it translates left or right, and it's going to be the opposite. So because it says -5, I know the vertex is at +5, comma, and then this number in the end is going to tell us where it translates up or down, and since it says +7, that means the vertex must have moved up 7. So there is our vertex of the graph, 5, 7, which is J. All right, next one. Just bring this down a little bit. Number 3. Jill throws a ball in the air. The function, which I'm going to go ahead and highlight, so this is the equation of the that models the height of the function. The graph of this function is shown below. I see that right here. It says, what does the y-coordinate of the ordered pair 2, 144 represent in the context of this problem? So let me go over 2, up 144, which it looks like that's right here at the top, which it looks like that's the vertex. Remember, it's a real-life problem, so it's going to go into the negatives, which doesn't make sense, but it's still a symmetrical parabola. And that's going to be not what time it takes for the ball to hit the ground. That would be this right here. The time it takes for the ball to start falling to the ground. Now remember, we're talking about the y-coordinate. So the y-coordinate is the height. So that's going to be the maximum height of the ball, because it's going to be as high as the ball gets to before it starts coming down. This one, number 4, I told you can skip. Number 5, how does the graph of 2x squared compare to the graph of x squared? So we talked about that even though this isn't really in vertex form, the number in front of the x squared is the dilation. And dilation is going to tell you if it's skinnier or wider. So there's your answer right here. The graph of f of x is a dilation because of this 2 right out in front instead of a 1. Let's do 2 more on this video. Ball is dropped from an airplane such that its height in meters above the ground is in this formula. So when it drops from an airplane, it's going to look like this, but it's a quadratic, because if you think of it the other way, it's going to form a perfect parabola. And where t is in seconds, how many seconds will it take for the ball to hit the ground? So one thing you can do is you can graph it. And if you graph it, you just want to find this point, which is, remember, you're going to calculate the zeros. Another thing you can do, which I'm going to show you, is you can use the quadratic formula, because quadratic formula is going to get you the 2 places where the parabola hits the x-axis. Remember, the second one is going to be where the ball hits the ground. So A in this problem is -4.9. There is no B because there's no t, so that's 0. And C happens to be 490. So negative b, which would be -0, but I could just put 0, plus or minus the square root of b squared. 0 squared is just 0, minus 4 times a times c, which is 490, all over 2 times a, which is -4.9. So first thing I'm going to do is I'm going to solve this. -4 times -4.9. So -4 times -4.9 is 19.6. So this is 19.6, and it's positive because you had a negative times a negative. So that positive 19 6/10 times 490, times 490 is equal to 9,604, all below the square root sign. 0 plus or minus, I'm just bringing this down, and then 2 times -4.9 is a -9.8. I'm going to try to see if this is a perfect square root, and it is, because when you do the square root of 9,604, you get exactly 98. So I have 0 plus or minus 98 over -9.8. Now, when I break this into 2 problems and I do 0 plus 98 divided by -9.8, you get -10. And when I do -0 minus 98, which would be -98, divided by -9 and 8/10, you would get a +10. So if you think about the problem, it's going to hit the x-axis at -10 and +10, which means it takes this problem, it would take 10 seconds for the ball to hit the ground. All right. Last one, a carnival game involves striking a board with a hammer that forces the ball up a tube. This is the function that forces that ball up a tube. So you know it's going to be a parabola, and it gives the height of the ball after t seconds. Find the maximum height of the ball. So that's going to be this right here. So remember, I'm going to go onto my graph, and I'm going to type in -16x squared plus 32 plus 3. And I'm going to graph it, and I'm going to go ahead and do that over here. And here's my calculator. So I'm going to go to second plus 712 to clear my calculator. So I'm going to do that. Second plus 712. All right, so I reset my calculator. I'm going to go into y equals, and I'm going to type in my equation, -16x squared plus 32x plus 3. I'm going to hit graph, and you're going to notice that you don't really see your whole graph. But I could see that if you look at my cursor right here, it just goes up and it comes down. So this is way too wide of a screen. So I'm going to change my window, and I'm going to change it, instead of the x max going all the way to -10, I just want it to go to 0. And then I'm going to change my y minimum. Instead of going all the way down to -10, I could just have it go to -1. I'm going to see what happens there. That's not good enough. It looks like I have to go way higher than the 10. So I'm going to go back to my window, and I'm going to go to my y maximum and change it maybe to 100. Maybe 100 is going to work. When I hit graph, that's way too high. So I'm going to go back down to my window, even though that might have worked for me, and change my y max to 50. And now I get a little better job. Now remember, all I'm doing is I'm going to calculate this point right here. So I'm going to go second, calculate, and I'm going to go to my maximum, left bound. See, right now I see that my numbers are at -139. So I'm going to hit left, and I can see it moving up closer. -43, -25. And then I can see my cursor right now. And I'm going to go left bound, which means to the right of the vertex. Right bound would mean to the right of the vertex. And guess would be enter. And that maximum is at 1 and 19. So that tells me that the maximum height of the ball would be 19 feet.